Pretty quickly, when new to Fusion 360, you get to a point where you need to import a model into the software. In this video, we will dig into what you need to know about importing into Fusion. Hi everybody, my name is Lars Christensen and thank you so much for taking the time to watch this video. So today we're going to talk about importing into Fusion, and we're going to take the essential steps on how you can take a solid model from another system, bringing it inside of Fusion, but then also some of these cool functions that Fusion has on how you can manipulate that model. Then we're going to talk a little bit about mesh data, specifically STL files. Now, with all these 3D printers out there, STLs are very common. So in this video, I want to show you a couple of the things that Fusion has on how you can work with the mesh data. And then we're actually also going to take that STL file and turn it into a solid body. Then in the end, I'm going to try to geek out and share some information with you that will let you totally dominate any conversation you have with your boss or your coworkers when it comes to importing data into software. Let's get going. Alright, so let's start here by importing a model into Fusion. The way I do it is I always use the data panel over to the left here. So you click the little cloud and then you can upload your file. Now in this case, I'm going to bring in a SolidWorks file into Fusion. So I'm just going to click on that SolidWorks file and hit open and then go down here and click upload. That's really all I have to do. Now this SolidWorks model is being uploaded to the cloud and goes through all the translations. So I'm just going to hit close here and then I can just double click to open up the model. So there's our model. Now let's talk about some cool functions that Fusion have when it comes to working with imported models. First thing I always like to address is if you look up here on the right, we have the view cube, and if I just click top here, I have to admit that this is not what I think is top on this part. And there is no rules for this, but I think we all have kind of like our preferences of what we like. I think what I like is, I think that what is back on the view cube is actually what I think I would like to be top. Well, it's extremely easy to change that inside of Fusion. All you're going to do is you're going to place it to the view where you want the model. So in this case, I want this to be top. Go up and right click and then go down and set current view as top. And just like that you can see up there, now this is the top that I wanted. So really all we did was we changed kind of like the camera position of the way we look at the model. Super handy. Now the next thing I want to talk about is being in direct mode versus parametric mode. So we have these two toggles we can do inside of Fusion, one being direct and one being parametric. Now in parametric we are capturing all the history we're working on, such as sketches and extrude and all those things. But there is actually a couple of neat functions you can do before you get into that mode. So if you've watched any other videos on importing into Fusion, it might suggest that the first thing you do is you go up here and you right click and you capture the design history. Now I'm not against capturing design history, but I want to show you a couple of the functions you can do before you get into capturing the design history. So let me show you. Now the first thing I want to show is that you have a move command in here. So the way you can do that is if I select that inside of that hole and I right click and I hit move, you will see that I actually get notified with arrows in here, and I can actually move this hole. So if we just had to do a couple of quick adjustments to a hole, for example, that would be a neat function. I actually have on this part a scenario we can look at. So if I go to the bottom of this part, you will see that there is a rectangular slot down here that was put in the native format, in this case SolidWorks. But as you can see, this pocket is not where, well, it's not centered between the holes, either in the y-axis or the x-axis. So let's go in and do that in this direct mode before we start capturing. So the first thing I'm going to do is I'm going to go up and I'm going to inspect to find out how much I want to move. And I'm first going to move the y direction. So I'm going to go down here and I'm going to snap over till I get that midpoint of that line. And then just going to select the edge. And it will show me down here that I have a center position of 0.603 to, who can remember? Well, look right underneath my cursor. It says click to copy to clipboard. All I'm going to do is I'm going to double click And now it just remembered that number for me. So I just double click right on that number to put it to the clipboard. Now what I can do is, if I go up here and I am just going to multi-select the different, let me get out of the measuring tool. I'm just going to multi-select these faces inside of the pocket here, right? Just like that, okay? So now it's selected by holding down the control. I've selected all those faces. I'm going to right click and hit move. And now you will see again, we get like the triads here, and I can now move things back and forth. So what I'm going to do is I'm going to do a Control V to paste that number in there. See that? That was the number we had before, so I didn't have to remember it. And then I can hit Enter to put that in there. And now we have just moved that pocket up in the Y direction. We can do the same thing in the X direction. So I'm going to do the same thing. I'm going to go into my inspection tool. I'm going to find the midpoint there, and then I'm just going to select that edge. And the distance there is this distance up here, right? 2.85. So I'm just going to double click to remember that. And let me open up my calculator and Control V to paste that number in. And that's going to be minus what? That's going to be minus whatever this value is from here to here. So that is this number. Double click, open up my calculator, Control V to paste that in, hit Enter, and then we're just going to divide that by 2, right? So that's the number we got to move it in X. So I'm just going to do here a Control C to copy that number. Now I don't need my calculator anymore. And then I'm really just going to go in and do the same thing we did before. So holding down Control, I'm just going to select, get out of the measuring tool, just select all these walls that I want to move, just like that. That should be all of them. I'm going to right click and hit move, and then again I'm moving the direction here, and I can just paste that number in that we need to move it, hit OK, and now we just moved that pocket over. We moved it up in the Y and we moved it over in the X. So keep this tip in mind. This is really great if you do have a CAD model from a customer or some other software where you just need to make a couple of adjustments. In this case here, moving the slot in the right location. Now the next thing I want to show you, I think, is almost magic. And that is, we actually can delete things in here, but have the software figuring out what needs to then patch up afterwards. If I, for example, go in and select this edge that goes around, or this round edge that goes around the part here, and all I'm going to do is hit the delete key on my keyboard, and you will see that Fusion is smart enough to delete that but also patch it up and make it a sharp edge. It's actually a pretty cool algorithm. Check this out. If I go over to this edge over here and I just select all these faces here, let's zoom in a little bit. Select these edges on here, and that one and that one. Again, if I hit just the delete key on my keyboard, you will see that I deleted that. Now you will see that it came up with a solution right here of adding kind of like two filters to this. But now I can do the same thing again. I can just select these two, hit delete again, and now I got a sharp corner. I think that those two functions, the move function and the delete function, can be extremely helpful. Again, think about that you get a call from the customer that they need to delete some holes that don't need to be in the model anymore. You can just go ahead, highlight that hole in this direct mode and hit the delete key, and the hole is patched up like it was never there. Now when you get to this point where you have done these couple of functions, then I will definitely recommend that you go up and you right click and you now decide to capture the design history. So from this point on, now if we go ahead and we right click here, we can now go ahead and create a sketch. You will see the sketch happens down in the feature tree, and we can now go ahead and do other things to this model. If we want to go ahead and sketch something, sketch a hole here, and we can now do our cuts and whatever we will normally do to the model and have it captured down here. So just a couple of handy tools when it comes to bringing a model into Fusion and what you can do with it like right off the bat. Now, the next thing I want to talk to you about is STL files. And this is like one of these interesting topics because STL files is really used a lot in 3D printing. So a lot of people have to deal with STL files. What is important to understand about an STL file is that it is not a solid. So a solid model, the computer knows there's something there. It's like a watertight model. But an STL file is almost like, think about taking a triangular fishing net and throw it over the 3D model, and that is what a STL file is. So an STL file is really just a thin shell made up of triangles. Some of the things to keep in mind about STLs is that depending on how fine or how coarse these triangles are, that can really change the shape of your model. So if you make a very fine triangular mesh, what you could be, thinking is always a great idea, then you will get a more accurate model. But it's also costing a lot of data, right? It's going to be a big file. And a lot of software have like limits, so they can only import like 20,000 triangles before the CAD software says I can't deal with this. The other, of course, problem is if you go too coarse, it can really change the shape of your model. Let's take a look at it inside of Fusion. So let me just close out of this solid model here. I'm not going to save it, I'm just going to leave it and go out to our data panel so we have that model there. Now let me import an STL file so we can take a look at that. Click the upload button here and say select file, and I have here a STL file. So let me go ahead and open up that file. And you will see here that you can see on this model here that it is made up of these triangles. So again, like I said before, think of like throwing a triangular fishing net over a solid model, and then that is what you kind of like ending up with. So in the past, there have actually not been many tools you could use to manipulate STL files just because it is this triangular mesh. But we actually have some new tools inside of Fusion that I want you to know about. So if I go up to the tab up here, the model tab, you will actually see that I have a new mesh tab. Now, this is in preview mode right now as I'm recording this video. So to be able to see this mesh tab, you actually need to know to turn it on. So let me show you. You go over to your preferences right up here in the upper right, and then you go into preview mode. And in here, you have all these different things you can turn on. And down at the bottom, you have Mesh Workspace. So make sure that one is checked. What this really is a preview to what they're working on the Fusion team. So with other software, they have like these secret beta forums that you kind of like have to do all kinds of things to be part of. But at Fusion, they make it available for you right here. You just need to know it's in preview, would mean that they're still developing on it, they're still working on it and polishing it up. So with the Mesh Workspace set, you will now see that you get this mesh button. So let me click on that, and you will see here there's a lot of different options in here, and I'll definitely recommend that you go in and you play around with some of them. The one I want to show you is called Erase and Fill. So this is actually a pretty neat tool. Now, if I go in here and I look at this pocket we had before, maybe I want to actually delete this pocket. There's a pretty cool selection tool in here called Paint Selection. So we are used to using windows inside our CAD, but we can actually also use a paint tool. What it does is whatever I'm kind of like hovering the mouse over, it will actually kind of like go ahead and highlight. So this is actually a pretty neat tool, I think, that I'm going to be using a lot to kind of like selecting things. So if I go in here and I just kind of like select these different areas and I then go up to modify, erase and fill, now you will see that we just completely tied up that pocket, and that pocket is now gone. So a pretty neat tool. Now from this point on, you can do other things, of course, within this mesh data. But to the end of it, you can actually go up and you can go in here, and now this file, you could say, is ready to be 3D printed. From here, you can go and you can choose whatever print utility you want to use, I always use Mesh Mixer in here, and just like that, your part is now ready to be printed. So I definitely think that these new mesh tools in here is going to be extremely handy. So be aware of that if you do get STL files. Now, the last thing I want to show you before we geek out with some really cool information about importing data is taking an STL file and turn it into a solid, because it is actually possible. Now, we have to do this outside of Fusion though. We have to use a program that for Windows is called Remake and for Apple is called Memento. So the easiest way to do that is going to Autodesk website and download either a trial, or of course if you're using it quite a bit, then you can go ahead and purchase a subscription for it. So let's check that out. So I'm going to go into my trusted Google here, and I'm just going to type in Autodesk, and I'm on a Windows machine, so I'm going to type in Remake and hit enter. And let's go in and take a look at the Remake website. So Remake is definitely a program that I think I'm going to have to create some videos about, because this is really awesome. You can do some really great things in here. But what I want to take you to is the try button here. And what you can do here is you can either download the trial for Windows or for Mac. And as you will see here, actually the price for this, if you're working with this a lot, it's actually not too much, $30. And like I said, you can do some great things with Remake in here. And of course, if you are a student or in education, it is free. But if you are just going to play around with this just to test it out, go ahead and go for the trial. The thing is that we cannot turn the STL file with its triangular mass into a solid. What we need to do is we need to convert it into what is called a quad mass. When it becomes a quad mass, then we can actually apply the T-spline technology to it that is already inside of Fusion, and that way convert it into a solid. That's why we're using Remake. Now, inside of Remake, we can go in and we can load the model here. And I'm just going to load that same STL file I brought into Fusion before. And again, inside of Remake, you can actually do a lot of cool things. All I am going to do is I'm going to go down and I'm going to export it out. And then I'm just going to say down in the bottom here, I'm going to export it out as a Fusion 360 quads. That's all I'm going to do. I'm going to export it back out to our desktop. That's really all I need Remake for. So pretty easy. Now, inside of Fusion, I can now bring in this quad, and you already get a hang of how we're importing into Fusion. So I'm just going to go ahead and hit upload, and then I'm going to select that OBJ quads file. Let that come into the software. And then we can go ahead and open that one up. Another thing that I think is really important to take a look at this model is that there has actually been some changes done to the model. This is one of the problems when you are translating data around, because every time you're translating data, it's really like taking German and try to translate it into Japanese or Chinese or whatever. Something can be lost in the translation. So when you look at this model, I want to point out that you will see that around the holes and around, well, really any sharp edges on this model before have now got a little bit of rounded edge to it. So be aware of that. But of course, if we're bringing it in and turning it into a solid, we can fix a lot of these issues inside of Fusion. It's just one of those things to be aware of. So we now have this STL file that has now been turned into a quad file. And now we're going to actually turn it into a solid by first turning it into a T-spline. So the way we're going to do that is we are actually going to go up and capture the design history. So now we will see down at the bottom, we now have that tree down there. Then I'm going to go up and say I want to create a form. That is going to tell me that I'm entering what is called the sculpt environment inside of Fusion. I'm cool with that. I love sculpting. So I'm going to say okay to that. Then all I'm going to do is right click on the model, and I can now go down and say convert. And what I'm getting, if you look over to the right, is I'm taking a standard mesh body and I'm turning it into a T-spline body. So let me go ahead and hit here OK. And now you will actually see that it has become a different type of mesh. What this is, the very, very powerful T-spline mesh that is with inside of Fusion. If you ever had to do wacky shape, then sculpting is definitely your tool, and T-splines is your tool. Now from this point on, all we really have to do is now convert T-splines into a solid. We can do that by just hit finish form, except in my case, you will actually see that I get an arrow. Isn't that awesome? It would have been easy if there was no arrows, but of course I chose a model where there was some arrows on it. It's easy enough to fix though. Let me show you. So let me just hit return to get out of this, and we can close the arrow. Because to my luck, of course, there is a repair body inside of the T-spline in Fusion. So all I'm going to do is select our model and say auto repair, and then I'm really just going to sit back and take a sip of my coffee, and the software will go ahead and solve this. So after a few seconds of wheel spinning, it comes back and says that it has finished the repair. So now let's try to hit the finish form. And just like that, the magic have happened. We have actually taken an STL file and converted it into a solid. Now some of you guys will agree with me that this maybe is not as pretty as it was when I brought in the SolidWorks file in the beginning. And that is of course, again, because we have taken triangular mesh like this fishing net over the model, and we have really just stretched it and gone through some different conversions. But this is a solid. We can work with this just like we would with a normal solid inside of Fusion. Now if you are interested in playing around a little bit with this yourself, I'm more than happy to share these files with you. So send me an email at lars@cadcamstuff.com, and I'll be more than happy to add you to this project. I did add my email address down in the description of this video, so just go ahead and send that. Alright, so let's geek out a little here. So what to know about solids? So one of the first questions many people ask is, what format should I ask for? So you need to get a file from somebody and they ask you, what kind of format do you want? And when you look in the drop down of what you can import into Fusion, there's a lot of things in there, right? There's CATIA, there's Pro-E, there's Rhino, or in the case that we used, SolidWorks files. So if you already know what format the other file was created in, ask for that. So they ask for the native file. But then there's also two other formats, neutral formats, that is worth to mentioning, and that is IGES and STEP. These two formats was created as neutral formats, so it would be easier to share files between different CAD manufacturers. So IGES was created back in 1980 by the US Air Force. Now they dragged in a bunch of other companies such as Xerox, GE, and other companies to come in and help them create this neutral format. And it's actually developed on the old punch card format. So you should actually be able to open up an IGES file in Notepad, and if you have a pen and a pencil, you can actually trace around the coordinates and you should draw up your model. Now STEP is actually ISO, it's 10303, and was developed in 1984 actually to replace IGES. But when they got in there, they actually found, because of the complexity, that they had to kind of like break it up into different AP kind of formats. So that's why when you open up a CAD system, sometimes you will see that there's different levels of STEP files you can bring in. The latest update to STEP was in December 2014, and it was version 242. Now, from us CAD users, it doesn't really matter what version we really are using. Now, if you open up a STEP file in a text editor, you will see that it's a lot more like an HTML type file, like almost like a web page. And there's actually some interesting things in there. You can capture a lot of metadata, also something like color in there. But most CAD systems don't really take advantage of these enhancements that are inside of STEP files. Now, IGES is definitely the most used of the two formats. Now, a fun fact is that they have not developed on IGES since 1994. That's a long time ago. So what format is best? Native, IGES, or STEP? Well, it really kind of depends. Look at each format as kind of like its own language. So if you have to translate something from German to Chinese, for example, you will get some some problems in the translation. And it can be the same thing when you're working with a CAD file. So what I actually prefer to do is I prefer to send all 3 files. Send the native file that I worked in and also save out an IGSS step. 2 reasons. Now it gives the other guy an opportunity to bring in and see what comes in best. But another thing I found is that everybody kind of seemed to have their favorites, definitely between step and IGES. So it's just much easier to just hand them one of each and then they can kind of decide what they want to do. So I really hope that you found this video helpful. As always, I love your comments and suggestions down in the comment area. I know a lot of people read them, and I can assure you that I read them all. And also, if you liked the video, if you don't mind, hit that like button. And if you haven't already, I would really appreciate if you will hit that subscribe button. Until the next time, have an awesome day.